All right, so I want to talk about a few things. The first thing I want to start with is the order of operations. So most people remember this as being PEMDAS. And you know that you're supposed to go through and do this from left to right or top to bottom, depending on how you write it. And it stands for parentheses and then exponents, multiplication and division, and then addition and subtraction. So I do want to make a big point right here is that most people will do all parentheses or grouping symbols. And we'll talk about that in a second. And then do all exponents, then all multiplication, then all division, and then all addition and all subtraction. But that wouldn't be right necessarily. The reason it's not is because multiplication and division get grouped together. So do addition and subtraction. That's the reason I've written it the way I have over here. So multiplication and division go together as well as addition and subtraction. So if you're going through a problem and you have multiplication and division, you're going to do it as you come to it from left to right. The same is true for addition and subtraction. Do it as you come to it from left to right. All right, let's talk about grouping symbols real quick. So these parentheses, which again, it's a word to remind us it's all grouping symbols. There's a couple of grouping symbols most people don't think about. One of them is a fraction bar. So if we have something like this, and we've got 3 plus 2 all over 2, or something like this. We know that we need to go through and do this addition first and then divide, but that seems out of order. The reason it's not is because this fraction bar is saying, hey, do the top thing, then do the bottom thing, then divide. So we would go through and do the top and then do the bottom and then divide. So this is like having invisible grouping symbols. Also, absolute value bars. So if we have something like absolute value of -7 minus 6, we have to go through and do this first. So if my entire problem was maybe something like 2 times the absolute value of -7 minus 6, I'm going to go through to the absolute value. I have to do that first. I have to complete that. So I'm going to have 2 times, and then this -7 minus 6 is going to be a -13. And then again, remember absolute value, once you've done this, like once you've made it into a number, to remove the absolute value bars, you're going to make whatever's inside positive. So it's going to be 2 times 13. So those are two of the trickier ones that most people don't think about. With grouping symbols, so with parentheses, which are the ones we normally think about, we have our parentheses, and that's what we do whenever we just need one set of grouping symbols or one layer of grouping symbols. But sometimes you need more than one layer. So outside the parentheses, we would go to brackets, and those are kind of the squared off looking guys. So you might see something like that. And then the next one, the next layer, was going to be braces. So these are the kind of funny, squirrely looking guys. And with grouping symbols, you want to start on the inside and work your way out. So if I had something like 1 plus 2 minus 3, and then we'll do 4 plus all that. I'd start on the inside. I'd have this 1 plus 2, which is 3. So then that would leave me with 4 plus, and then 1 plus 2 is going to give me 3. So that was in my parentheses, and then minus 3. So now I have 4 plus 3 minus 3, or 4 plus 0. And actually, I didn't go through and use all of those, but just kind of give you an idea. Start on the inside, work your way out. All right, let's actually get into our first example. So for our first example here, we have 4 divided by 2 times 1 plus 3. Again, parentheses, those are going to come first. So we're going to do this 1 plus 3 part first. So you're going to have 4 divided by 2, and the 1 plus 3 is going to give us 4. Now this is an example of where multiplication and division go together, and you're going to do it as you come to it from left to right. Because all I have left is division and multiplication, or because I'm on that step really, I'm going to go through and I come to this division first. So 4 divided by 2 is going to give me 2. So I'm going to have 2 times 4 is what will be left, and then that'll be 2 times 4, which will give us 8. And again, a lot of people are going to make the mistake on that problem of working it out and getting 1/2. So do look out for that. All right, let's look at our next example. So we have 2 times 3 squared over 2 times 3 in parentheses squared. So let's start off again remembering that the top and the bottom of the fraction, it's like having invisible grouping symbols. So we're going to work out the top and then we're going to work out the bottom. Or we're just going to work them out separately. You could work out the bottom first if you wanted to. So looking at the top, this 2 times 3 squared, I know I'm going to do my exponents first. So before I do my multiplication, so I'm going to have 2, and then times, this 3 squared is going to be the same as 9. And then my last step is just to multiply, so 2 times 9 is going to give me 18. And then on the bottom here, the 2 times 3 is in parentheses. So I've got to do that part first. So to remove my parentheses, the 2 times 3 is going to give us 6. So we're going to have 6 squared, which will be 36. And then this will reduce down to 1/2. And if you're wondering why the reduction happened, so 18 over 36, they're both divisible by 18, but maybe you wouldn't notice that. But hopefully you would notice that they were both divisible by at least 2. So if you divide these by 2, we're going to end up with 9 over 18. And then hopefully here you notice that both of these are divisible by 9. So we would reduce again, be left with 1 and 2. All right, let's look at our third example. So we have 10 divided by 2 times 3 plus 1 times 2 minus 4 plus 2. This looks like a big, long problem. But again, order of operations, we're going to start with our grouping symbol. So we want to focus in right here, this 3 plus 1 times 2. And within that grouping symbol, we still have to observe the order of operations. So we have addition and we have multiplication. We're going to do the multiplication first. So I'm going to write out more steps than I think most of you probably would, but just I want to show you exactly what this would look like. So this 3 plus 1 times 2, we do the multiplication first. So it's going to leave us with 3 plus 2 inside of our parentheses, and then minus 4 plus 2. And now again, we're still working inside these parentheses. So 10 divided by 2 times, and now 3 plus 2 is going to give us 5, minus 4 plus 2. All right, so our grouping symbols are done. We didn't have any exponents, so we're looking for multiplication and division. And again, we're going to do it as we come to it from left to right. So this 10 divided by 2, so what we're going to look at first, 10 divided by 2 is going to give us 5. So this is going to be 5 times 5 minus 4 plus 2. It's okay for me to drop the parentheses in this step or in this one, because once we've done what it says to do inside of it, I'm still just multiplying here. So 2 times 5, I'm wanting to make sure that I'm doing the times 5. So again, all we've done from the green to the blue is taken this 10 and divided by 2. So we did that to get 5, and then we've worked the rest out. Okay, let's get to our next step. So again, we're still in multiplication and division. So we're going to do the 5 times 5. So this is going to give us 25 minus 4 plus 2. And now we're just down to addition and subtraction. So we're actually almost done. So this 25 minus 4, we want to do that. So 25 minus 4, and again it's subtraction, but we're going to do addition and subtraction from left to right. So 25 minus 4, this is going to give us 21 plus 2, and then our last step is just to add, so we're going to have 23. All right, so you might be wondering, why do we do this big review on order of operations? Well, we did it because it's really important whenever it comes to putting really long formulas, or not even really long ones, but using formulas and using your calculator. So we want to be able to get these formulas into our calculator properly, but to do that, we have to make sure that we're telling the calculator what we mean, what we actually want it to do. With something like this, let's this is an example with the compound interest formula. So the compound interest formula is A equals P onto 1 plus R over N to the NT, where A is your accumulated amount. That's your ending amount. So um, that's going to be the amount that you owe in total or the amount that you've earned. So if you put an investment in the bank, this is what you would have in your bank account after however many years you had it invested. Things like that. Your principal is your beginning amount. So that's going to be the initial amount of the loan or the initial amount of the investment. Your R is going to be a rate, so whatever your interest rate is, but you have to make sure to use it as a decimal in this formula. N is going to be the number of times this compounds per year. So if it says monthly, that'll be 12. If it says weekly, that'll be 52. If it says daily, that could either be 360 or 365. You'll want to make sure you read those instructions carefully. If it doesn't say anything about 360 days, you'll want to use 365 because some banks still use 360 days in a year. And then T is going to be your time in years. All right, so if we have this example and we're trying to find the accumulated amount, so there was $15,000 to begin with. This 0.042, that's our interest rate already converted over to a decimal. And just for fun, let's go through and label everything that we have. So our principal for this example was $15,000. Our rate as a decimal is 0.042. That means it started off as 4.2%. You're going to move your decimal point 2 places to go between decimal and rate and percentage, and your percentage should look larger. And then here on bottom, so on bottom we've got that N. This is going to be the number of times it compounds per year. So if N is 12, that means it's compounding monthly. And then up here we have NT, and then our T is 6. So that's going to be for 6 years. So again, just looking at what was plugged in the formula, we can go back and see this breakdown here. All right, so the problem is we can't put our fractions in like this with our TI. We actually need to make sure that we can write this all out in one long statement. So this is going to be 15,000 times, so this part we can start off properly, or the way it looks. So we've got 15,000, and then times 1 plus, and now this is the division we're going to have to write out. We can't use a fraction bar. So 0.042 divided by 12, and then I'm going to close those parentheses. Now I want to point out that it's okay that we don't have to put extra parentheses around this. The reason we don't is because the order of operations is going to do the division first and then the addition. And now we need to raise those parentheses to the power, which is your little caret button, to 12 times 6. Well, again, this exponent here is acting as a grouping symbol. So I need to make sure that I'm putting 12 times 6 in parentheses because I want the whole exponent, the 12 times the 6, not just the 12. So let's come over to our calculator and see what we get real quick. So we got the 15,000 times that 1 plus 0.042 divided by 12 to the power of, and again, remember your parentheses, so 12 times 6. So for this one, we're going to get $19,290.45. We're talking about money here, so it's going to make the most sense for us to go through and give our answers out to the hundredths place. So $19,290.45. So not too shabby. We had $15,000 that we invested at 4.2%, and it was compounded monthly, so 12 times per year for 6 years, and we ended up with over $19,000. It's a pretty nice investment. So with this example, we went through and we were to increase the number of times per year that this was compounding. We would get more and more interest. I'll do a quick example actually before we get to example 2. So I'm just going to take this exact same thing that we had here, and all I'm going to do is change out where my N was, so where those 12s were. So I'm going to erase that 12 and that 12. And I'm going to choose to change that from 12 to, let's do compounding daily, so 365. So I'm going to come back over to my calculator. And again, where these 12s were, I'm going to change that to 365. So instead of compounding monthly, I'm going to be compounding daily. Well, I can go back and retype this whole thing, or shortcut, if I hit second, enter, that's going to pull up my last line, and I can just go back in here. So 365, so 3, 6, and I need to insert the 5. So second insert, 5. I'm going to do the same thing over here. So 365, the 36 fits, but I've got to insert that 5. So now this is compounding daily. And if you look, we're making like a little over $8 more because it's compounding daily instead of monthly. So compounding daily, we ended up with $19,298.66 versus the $19,290.45. So it makes sense that if we kept increasing the number of times it compounds, so maybe you wanted to do compounding twice a day, or compounding hourly, or compounding every minute, or every second, or even more. Well, what happens is that for compounding continuously, which is it is compounding continuously, constantly, we have this nice little formula, A equals PE to the RT. A is still your accumulated amount, P is still your principal, R is still your rate as a decimal, T is still your time in years. The E, this is Euler's number. So it's a constant, just like pi is. So it's just a number, it's a button on your calculator, which we'll get there and I'll show you where it is in just a second. So for us to be able to do a comparison, these are actually the same information as up here. So the 15,000 is our P. The R, our rate, is still that 0.042, which is 4.2%. And that 6 is still our time, so still 6 years. So to put this in our calculator, it's actually easier than our first example. The reason it'll be easier is because we're going to have that 15,000, then times E, and then here's the only part that we need to worry about. So to the power of, we want this whole thing to be the exponent, so we need parentheses. So 0.042 times 6. So we'll come over to our calculator, and we've got that 15,000 times, and then our E, if you do second, and then come down here to the ln, that's going to give you E to the power of, and open the parentheses. So your calculator is going to try to remind you. So the 0.042 times 6, and then we'll close our parentheses. And if you look, we've made just a little bit more money than we did compounding daily. So if you look here, it's less than 30 cents difference. But with compounding continuously, we made $19,298.94. So still nice return, and every penny counts, right? So it's still useful. So $19,298.94. And that's a very bad, but a 19. All right, let's get into some more formulas. So here, this formula over here is the value of an annuity. So with the interest compounding in times per year. So an annuity is going to be something where you're putting money into it a certain number of times per year, and it's a way to save money. So maybe you are setting aside $100 a month or something like that. This is the kind of formula you would use to figure out how much you're going to have after 20 years or something along those lines. So let's come back over and again look at our problem and look at our formula and figure out what the scenario is with this given problem. So again, the P, and the P is going to be the deposit made at the end of each compounding period. Wow, so this is depositing $15,000. It's a lot of money, right? So P equals $15,000. Then we come back through. The 1 is built into the formula. this 0.012, that's our rate. So that 0.012 is the same as 1.2% for our rate. 52 on bottom, that N. So this is going to be compounding 52 times per year. And again, so that means we're putting in payments 52 times per year. And then this 10 up top, that's going to be for 10 years. All right, so let's figure out how to put this in our calculator. So this is where some of the invisible grouping symbols are happening. You got to remember, this is one part, and this is one part. So we want to get the whole top in before we divide by this fraction. So I may not be able to get this all in one line, but we'll try. So we're going to have 15,000. And then, so we are opening two grouping symbols here. So because we're not going to use our brackets and braces in our calculator, we're just going to use parentheses. I'm going to start with double parentheses. So I want to make sure that I get all of this into one thing. So 1 plus 0.012 divided by 52, close parentheses. So this is still kind of matching what's going on. And then to the power of, and then the 52 times 10, I'm just going to need parentheses. So 52 times 10, close parentheses. All right, let me move this real quick. So far we've made it to this part, and we have to do -1. And then we need to close that. Now, this matches what's written up here. But remember these parentheses that I put in red. So the entire top needs to be divided by this fraction down here. So I'm going to put parentheses actually on the outside as well. So these are the red ones. So we've ended up with double closing parentheses over here. All right, so we've got that far. Now I'm going to divide by this part right here. And we don't need these double here because we already have the parentheses. So divided by, I'm going to open my parentheses, that's 0.012 divided by 52 and close parentheses. So this part up here is the entire top. And then this little bit over here is the entire bottom. Let's put that in our calculator and see what we get. So we're going to start with parentheses, 15,000, and then again, double open parentheses, 1 plus that 0.012 divided by 52, close parentheses to the power of, and again, we need that 52 times 10 to be the exponent, so that's also going in parentheses, -1, and then I need to do a double close. So I'm going to pause for just a second. So right here, these last two bottom lines are what we've entered in so far. So I want to make sure that I have the same number of open and closed parentheses. So opening, I have 1, 2, 3, 4. So for closing, I should also have 4. So I'm going to come back through, and there's 1, 2, 3, 4. So I'm feeling pretty good about making sure I'm closing everything properly. All right, so there's the top of our formula. Then we're going to divide by parentheses, that 0.012 divided by 52, close parentheses. And again, this part's easier because we just know we opened one and closed one. And wow, look at that amount of money. So $8,286,280.77. Wow, right? But the way this annuity, what this annuity is saying is that we're putting in $15,000 every week. So we were expecting it to be a pretty large amount of money. So $8,286,280.77. So for fun, let's see what this would have been without the interest. So this is the answer that we were after. So without interest, we would have had $15,000 and we would be depositing that 52 times per year, and then we would do that for 10 years. So this is going to give us the amount of money without the interest. So back over to our calculator, that 15,000 times 52 times 10, so that's going to give us $7,800,000. That's a pretty significant difference. Definitely worth investing your money, right? So maybe this was a company. Or maybe this was one of your all's investments after you've graduated. So $7,800,000 was without any interest. That was just the amount that was deposited. This $8,286,280.77, this is the total amount after the 10 years. All right, let's look at another one. So most of us won't be depositing $15,000 a week for 10 years, but maybe we have a financial goal in mind and we want to figure out how much money we need to put in to get there. So that's what this formula is for. It's the payments needed to achieve a specific annuity value. So to figure out your accumulated amount or your goal amount. This formula is actually very similar to this one. If you were to look, if we multiplied both sides by Rn and then divided both sides by everything except the P, you would end up with this formula. If you don't see that, that's okay. You'll have both available. All right, so I want to break this one down again also and see what we're talking about. So this 25,000, that's our goal amount. So that's our A. And then this top number, this 0.023, that's our R, which means 2.3%. This 12 is our N. So it's going to be monthly that we're making these payments. And then we'll come down to the bottom and we see this is all information we already have, and then 12 times 15. That 15 is going to be the T. So we are hoping to get to $25,000 in 15 years, making monthly payments with an interest rate of 2.3%. That's what's happening right here. All right, so to get this in our calculator, again, remember that the top and the bottom are like grouping symbols. So I'm going to have parentheses around the top. We already have brackets all the way around the entire bottom, so I don't need to write those in. So this will be P equals, and again, I'm going to write it how we would for our calculator. Minus. So P equals 25,000 and then times 0.023 divided by 12. I'm going to close parentheses twice because I've opened them twice so far. So there's my top, and then divided by, and then for the bottom, I'm going to switch to black and come down here. So divided by. I have two grouping symbols opening here. So I'm going to open two. So 1 plus 0.023 divided by 12. And here I'm closing one set of parentheses. So this is what's in parentheses here. Then I need to raise that to the power of 12 times 15. So to the power of, I'm going to need parentheses again because that 12 times 15, they're both in the exponent. And then minus 1, and then close parentheses. So this is the bottom. I want to make sure it looks like I have the right matching parentheses, but I'm going to double check. So on the bottom, I have 1, 2, 3 opening, and then 1, 2, 3 closing. So let's put this in our calculator and find out how much money we need to set aside every month if we want to save up $25,000. So again, open parentheses, 25,000, and then times that 0.023, divide by 12, close that twice, so there's the whole top, divided by, double open parentheses, 1 plus 0.023 divided by 12. Close that. To the power of, and again, the exponent is that 12 times 15. So that's going in a set of parentheses. Minus 1. We're going to close the whole thing. So that's actually not too bad, right? So our final answer on this guy is going to be $116.44. Pretty awesome. We only have to set aside a little over $116 every month for the next 15 years to get $25,000 if we can find a 2.3% interest rate.